Alrighty, guys, welcome back. We're gonna actually end up going over the first two of these problems, and then probably we're gonna do. Let's see. We're probably also gonna do number 3. So we're gonna do 3, 2, and then 1. And if you guys have questions after that, then I would love for you guys to just come reach me during class, during work time, and then I'll do a small group with you guys here. I feel if I do 1, 2, and 3, it'll be a good catalyst or a good kickstart for the rest of them. And if not, please email me or kind of grab me during work time or advisory. All right. So let's get started. So in order to do this, you will need a periodic table of elements. So you will need one of these suckers right here. Okay, mine just so happens to be color coded because I printed mine that way. Please do not ask me for a color coded one because that I will not provide that. Awesome. All right, so now for this particular subset of problems, just adjusted it. Nice. All right, so you have sodium chloride, which is this one, reacts with magnesium oxide, right? And it produces sodium oxide and magnesium chloride, right? So what type of reaction is this? Well, you have Na swaps places with Mg, so this is a double replacement reaction or a double displacement. Now let's see if it's balanced, right? More than likely it's not going to be, right? So let's see. You have how many Nas on the left? Well, you have 1 Na on the left. You have 2 NAs on the right. And I'm going to go ahead and stop there, right? Obviously, they're not going to be balanced. So what number could I put in front of here to balance the NAs? You guessed it. I could put a 2, right? And so now I have 2 NAs. I have 2 NAs over here. Now let's look at CLs and see if they're balanced, right? So 2 times 1 CL is going to be 2. Okay, I have 2 CLs over here, so those are balanced. Let's look at magnesium, right? Magnesium, I only have 1. I only have 1 on the right side. And then let's look at oxygen. Well, I have 1 oxygen here and 1 oxygen here. So my equation is already balanced, right? So perfect. Now I'm going to put my 1s here because that's the same thing, right? We call these ninja 1s because even though they're not there, they're actually there, right? Okay, now let's start off with question number 1. So before you even start these, you always want to make sure that you balance your equations, right? If you want extra credit, you should also name these, right, off to the side. So name the type of equation that you actually have. I won't actually give you extra credit, but it's really good practice. All right, question number 1. If 24 grams of sodium chloride, okay, reacts with an excess amount of magnesium oxide, how many grams of sodium oxide will be produced, right? So here's what you have. You have a whole bunch of terms thrown your way, so let's identify what you have first, right? So you always start with what you have. You have 24 grams of sodium chloride, so NaCl over 1. And what are you trying to get to? Well, it reacts with an excess amount of magnesium oxide. How many grams of sodium oxide will it produce? So you're trying to get to sodium oxide, specifically grams, right? So now, here's the pickle, right? Here's kind of the dilemma. I can't go from grams of NaCl to grams of sodium oxide just willy-nilly, right? When we did our molar ratios on the previous problems, we converted, we already had moles, right? So if we had moles of NaCl, heck yeah, we could just go straight to moles of sodium oxide. But since we don't, what we have to do is we have to convert this into moles of NaCl. So enter dimensional analysis from last quarter. So if I have grams of NaCl up here, I'm going to need grams of NaCl down here. And I'm trying to get to moles of NaCl. Right? And so, in 1 mole of sodium chloride, how many grams are there? Right? So that's when we pull out our periodic table of elements. Here we go. So, chlorine has an atomic mass or molar mass of 35.45, and then sodium right here has an atomic mass of 22.9, so we're just going to round that up to 23, and 35.45. So when we add those up, so 23 plus 35.45, that's going to give you 58.45. Right, that's how many grams are in 1 mole of sodium chloride. So 58.45. So 58.45. Hopefully you guys can see that. Nope, I can see it. Perfect. All right. And now, I'm not done yet because these units cancel off, right? Grams and grams, and I'm left with moles of sodium chloride. Well, I don't want moles of sodium chloride, I want moles of sodium oxide. So now, if I have moles of sodium chloride up here, I need moles of sodium chloride up here. And then I'm trying to get to sodium oxide, but I can't jump from moles of NaCl to grams of NaCl, but I can certainly go from moles of NaCl to moles of sodium oxide. So mole sodium oxide, which is Na2O, and that's this problem right here. Okay, so let's go back to this equation. What is my ratio? Well, for every one NaO2 or Na2O, I have 2 sodium chlorides, right? And now I'm not done quite yet, because if I do that, then I'm left with moles of Na2O, and I don't want moles of Na2O, I want grams of Na2O. So if I have moles of Na2O up here, I'm going to need moles of Na2O down below. And I'm trying to get 2 grams of Na2O up there, right? So in 1 mole of Na2O, how many grams do I have? Well, let's go back to our periodic table of elements, right? Sodium, once again, is 23, but you have 2 of them, so that's going to be 46, plus oxygen, which is 16, so 46 plus 16, right? Do this, good old fancy math, bam, bam, you get 62, right? And I'm going to put that number up there, and now I cross these units off, and I'm left with grams of Na2, which is what I want. And now you multiply all these up top and divide by the multiplication of all these down below. Okay, that was a lot to take in, so let's do one more practice problem. I'm going to go a little bit faster on this one, just because I feel like I gave a pretty detailed intro. So if 53 grams of magnesium oxide, that's what you have, reacts with excess amount of sodium chloride, how many grams of magnesium chloride will be made, right? So you start off with 53 grams of magnesium oxide, so MgO, over 1. All right, and then how many grams of magnesium chloride, right? So MgCl will you produce? So let's go through this one more time. I'm trying to go from grams to mole, or from grams to grams, but in order to do that, I have to go from grams to moles first. So if I have grams of MgO up here, I need grams of MgO down below, and I'm trying to get to moles of MgO, right? And then in 1 mole of magnesium oxide, I have how many grams? Well, let's look at our periodic table of elements here. Magnesium has an atomic mass of 24.3. So 24.3, I'm going to do it onto the side, 24.3 plus 16, right? And so that's going to give me, let's see, 40.3, right? Now, I'm left with moles of MgO. Okay, and now I can go from moles of MgO to magnesium chloride. So if I have moles of MgO, I need moles of MgO. And then I'm trying to get to moles of MgCl2, right? MgCl2. And so the ratio for this bad boy right here is, for every 1 mole of MgO, I produce 1 mole of MgCl2, right? Just so happen to work out that both of them are 1 to 1. And now I can do my final step. If I was being asked for moles of magnesium chloride, I would stop here, but I'm asked for grams, right? So now I do moles of MgCl up here. So I need 1 mole of MgCl2 down below is going to give me how many grams of MgCl2? Well, once again, let's look at our periodic table of elements. Magnesium has an atomic number of 24.3. Plus, you have 2 chlorine atoms over here, which chlorine is 35.45. So 35.45. Since you have 2 of them, you're going to get 70.9, right? And you add these 2 up. I don't know why I did that, but you add these 2 up, so bam, bam, that's going to give you 2, 1, 5, 9, 95.2. So 95 0.2. Multiply all these across and then you're good to go. Now let's do number 3 so I can get you guys started. It's a different equation, right? So first we're going to balance it and make sure both sides are balanced. I have 3 magnesiums on this side. So I have 3. I have 1 magnesium on the other side, and that's a bummer, right? Because then they're not balanced. So I'm going to put a 3 here and see what happens. So now I have 3 magnesiums on this side, 3 magnesiums on this side. So these two are balanced. And then let's see, now I have 3 oxygen on this side, so 3 times 1, and then I only have 1 oxygen on this side, so I'm going to put a 3 here, and so now I have 3 oxygen and 3 oxygen, so my oxygens are balanced, right? And so let's see, what do we got? How many potassiums do we have? Well, we have 3 times 2 is going to be 6 potassiums. And then we only have 3 here, so I'm going to put a 2 here. So 2 times 3 is 6, so potassiums are canceled off. Now let's look at nitrogens, just for fun. N2, right? Oh, this should have been a subscript. I'm so sorry, guys. So this should be a tiny little 2 here, sorry. So N2, I have 2 nitrogens. And then 2 times N1, so I have 2 nitrogens. So this is my balanced equation. And I can just put a 1 here, my Ninja 1. Now let's get into this question. 14 moles of potassium oxide, so K2O, all right, 14 moles of K2O reacts with an excess amount of magnesium nitride. How many grams of potassium nitride will be produced, right? So how many grams of potassium nitride will be produced? Potassium nitride right here. Bam. So let's go ahead and start off. I have moles of K2O. Notice you're already given moles. In this one, you had to go from grams to moles. So right here, I'm already in moles, so I can go straight into my molar ratio. So if I have moles of K2O up here, I have moles of K2O here, and I'm trying to get to moles of K3N. So K3N, and then that's mole. What is the molar ratio of each? So for moles of K2O, I have 3. And then for moles of K3N, I have 2. And if it was just asking me for moles of potassium nitride, I would stop here, but it's asking you for grams. So I have moles of K3N up here, and then I'm going to have 1 mole of K3N down here. And I'm trying to figure out how many grams. So grams of K3N in 1 mole of potassium nitride. How many grams are there in there? Or so how many grams are in 1 mole of potassium nitride? Well, let's look at our periodic table of elements. Potassium has an atomic number of 39. Oh, that's a horrible number. All right. Well, it has an atomic number of 39. And there's 3 of them. So that's going to be 120 minus 3, 117. So I'm going to write this down here. Hopefully you can see it. 117 for potassium. And then nitrogen has an atomic mass of 14. So I'm going to add that on there as well. So I add these up and then I get 1, 1, 3, 1. So 131 grams. So bam. And now I can cross off my units to see if I'm left with the desired unit. So moles of K2, moles of K2, moles of K3N, moles of K3N, and I want grams of K3N, which is what the problem was asking for, right? Perfect.